Alrighty, let's see what we got today. It's easy, similar to yesterday, using bits, maybe. Reverse bits of a given 32-bit signed integer. So n is this, but then that's not, this is the binary version of it, and the output's the reverse of it. Okay. Alright, let's see if I can do this in Python. So in Python, you have your bit operators, like binary and, binary or, binary XOR, and accessing those binary operators or using the binary operators on the integers themselves without needing to convert it, because converting it doesn't really do much, I guess you can say, besides the representation you might see when you print it out. No, actually, I don't think. The representation you see when you print it out depends on how you do the printout, I want to say. In any case, the integer is still stored as a binary in data format, and you can still perform the binary operators on that. So I think what we need to do is just parse the bits of the integer using binary operators. In particular, you could, in theory, also do this with kind of decimal operators or decimal arithmetic, but I'm going to use the binary operators because this kind of seems more appropriate in this situation. So I'll do something like while n is greater than 0, so I'm going to remove removing kind of last bit each loop here. The last bit is going to be equal to n and binary and, or bitwise and 1, because bitwise and would just be would not 0. If it's 0 and with 1, then that's going to be 0, which means that actually, is this right? Actually, is it using binary operators? I guess I'm using, no, that's not it. Using bitwise operators, particularly I'm going to use shift. So if I shift this thing, all these bits to the left one, no, to the right one, that will remove this last bit, which is like the ones bit. And when I shift it, it returns that last bit. So is equal to n shifted over 1. Actually, I think that doesn't modify n. If it shifts over, it doesn't actually return anything. Well, it returns the shifted over value. I guess maybe I do need binary operators. And shift over, I think it's shifted over equal 1, which is equivalent to n is equal to n shifted over 1 to the right. What, I feel like this should be n and bitwise and with 1. Okay, yeah, okay, that's right. Yeah, because this is equivalent to having a bunch of zeros before the 1 and then the final 1. It does a bitwise operator on each prior bit before it, so it'd be a bunch of zeros and 1s. All the zeros, bitwise and with 0, 0, all the bit, and then the last one, whatever that value is, becomes that. Okay, and then I guess I'll say the reverse answer, or the reverse of it is going to start with 0. And then what do I want to do here? I want to push the reverse shift it over to the right one plus the last bit, and then return the reversed. I think that's right. Oh boy, that's definitely not correct. Well, I didn't change n. Well, no, n shift over to left one. I did change n. Alright, let's go ahead and just print out what guess I can't print out what reverse shows, because it'll be in decimal form at that point. I guess let me go ahead and just do an array and see what the array has. Let's see. I think I need something easier to, well, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 0. Okay, actually, this is correct. But the output's 0, interesting. This binary array has the same bits as the binary answer that I want. So reverse shifts over to left one plus the last bit. I mean, I think that's right. Okay, let's go ahead and just print out what the reverse actually has at each stage. Sha-la-la-la-la. It's all zeros. Zeros all the way down. Why would that be? I mean, I guess I could separate this out. I could say reverse, shift over to left one, and then reverse plus last bit, or plus equals last bit. I think that should be the same though. Okay, it's not. Wait, this one's not even the same anymore. Is it not the same? It's missing the, oh, it's missing, then this needs to loop 32 times exactly, since otherwise it doesn't do these last bits, because I think it's, yeah, this needs to do exactly 32 times. Or I in range 32. I guess I can just do underscore since it doesn't even track the actual index. Okay. I wonder what's the difference between this and this. Reverse shifted over 1. That should have returned value, no? Do 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 do. Good old y is let's say x equals x plus bit different than x equals followed by x plus equals 1 in Python. Why? Precedence operator. Really? Plus is higher precedence than the shift? What the heck? Okay, I guess that makes sense. That definitely makes sense. So I just need to put parentheses around it. Makes sense why the code doesn't work, but I don't know why shifting would be lower precedence than addition. Huh. Okay, whatever. Get rid of the array, and I think that's it. Parse the bits of the int using using bitwise operators, bitwise and operator, removing last bit using shifts, bitwise shift. Okay, let's go ahead and run it. Wow, that's really slow. Okay, okay. I guess maybe last bit here is a little extra. I think I can just do last bit is what is n doing here? Oh shit, this is not necessary. I no longer have n. N was using as the index until, or no, actually I didn't need n. N is shifting over 1, right? So I think maybe I should do this first and remove the last bit. Plus n and 1 less, and then n shifts over. Okay. Still 52 milliseconds is a little slow in my mind. Okay, still too slow. So I need to do this 32 times exactly. I wonder, is there math behind this? Is there math behind this? Could I do this as a subtraction? It's a signed integer. Do all the numbers add up to all the ones? No, I don't think so, right? So if I'm dealing with, let's say 16, so that'd be, let's say I'm dealing with, okay, I guess this is 1, 2, 4, 8, so that's, yeah, 16 values. And I want to go 0, 0, 0, or 0, 0, 0, 1 to 1, 0, 0, 0. I mean, it is equally 16. This is 8. This is 1. 8, 1. I guess I can make an array here. Oh no, that doesn't make sense. Reverse shift over to left 1 plus the last bit in n, and then shift the last bit in n. I guess uh, hmm. I wonder if I should just use a static array of 32 values here. Static array of 32 values so that I just iterate over those values. Yeah, okay. Let's go ahead and do kind of powers for everything in range 32. And say the place is starting with 1. I guess I need to first append it to the powers appends place. Is it append? Sure. And then powers append the place. And then place shifts over, bitwise shift over to the left 1. And then print powers. Place powers. Oh my god. Wow. Powers append place. Alright, alright. Although it should be kind of reversed. First bit, second bit. Yeah, it needs to be reversed, I think. Alright, so this is powers is equal to that. Pre-compute powers of 2. Alright, so these are the powers. So I don't need to use n, I can just iterate over reverse. Well, I don't need a shift over n, I guess. I do need to still. Do I need to do this reverse? The first one still gets shifted. Whoops, I don't need a reverse. Shucks. Gosh dang it. Invalid syntax. Excellent. All right, so this is powers. Okay, so there's that. And then for everything in range 32. So I don't think this should iterate over the powers. For all the powers, and for every power in powers, it's going to do the bitwise and of n and that particular power. And then it doesn't need a shift. Okay. Oh my god. Oh lord. That's really bad. Okay. Bitwise and one spot. Oh shucks. Now yeah, it's gonna bitwise and it's gonna be in the wrong spot, isn't it? It's gonna be in the wrong spot. Because if it's the second one here, it's gonna keep in the second spot rather than be in the last spot. Well, is it? Yeah, it is, because it's not in the right spot. Shucks. I had... guess... Guess I need to convert it from anything to 0, 1. Uh, hmm. Tricky, tricky. I guess I can do if this is true, then reverse is equal to reverse shifted over 1 plus 1. Else reverse is equal to, or reverse is only shifted over by 1. Okay. Okay, this is true means that there's any one bit, and that one bit would be the one that's turned on when I do this bitwise operation. But it's not always the last bit. Back to slow town. So I saved kind of on save one operation, then add another operation with this if condition. I don't know. I wonder if there's some just binary library that I should be using in Python. If this function is called many times, how would you optimize it? Well, I'm trying to optimize it right now. Reversing it. Zero, zero, bunch of ones, then another 0. 0, 0, bunch of ones, another 0. Hmm. Oh, wonder. Is there a way to? I mean, I initially tried shifting. Okay. In Python, actually, I'll just Python when shifting, when using bitwise shift operators, is there a way to remember the discarded bit? No built-in way to remember the discarded bit. Yeah, capturing it is using the bitwise and with 1 before shifting. You can perform both operations simultaneously using a tuple unpacking to keep your code concise. X and the bit X shifted over 1, X left shift, which is what I'm doing. Bit X bit. The last bit is, what is this? No, I'm doing the right bit. Oh, for 8. Oh, okay, I see. Left shift is for the most significant bit, so it needs to shift over. I don't even know. What is this? Anyways, it's this. Perform both simultaneously using a tuple unpacking to keep your code concise. The thing about Python's integers use arbitrary, they do not have a fixed bit width where bits overflow during left shift unless you manually apply a mask. I think the mask is the bitwise AND operator. Or something like that. The carry bit. Sure. Carry bit, carry me away. Oh. Wonder. Like, what is causing this thing to be so, to these solutions be so much faster? So much faster. For every bit in range 32, the reverse answer. I wonder if bitwise operators is faster or is bitwise shift right by 1 faster than multiplying by 2. Bitwise shifts are generally not significantly faster than multiplication. In some cases, it can be slightly slower due to Python's interpreter can handle small integers. For extremely large integers, 2 times 10 to the 2 to the power of 1,000, bitwise shift can become noticeably faster. Yeah, okay. I mean, I guess I can try it. So it'd be multiplied by 2 plus 1. I feel like this is not going to be any fast. Yeah. So let me go back to the previous way. This powers thing doesn't seem to. I think this thing is actually kind of. I don't know. I don't know. So it'd be something like reverse times equals 2. Reverse times 2 plus that last bit. And then n is divided by equals 2. Divided integer division. Okay, I mean that's as fast as I've ever made this compared to all the other submissions. 47, yeah. I mean, I don't think it would be any faster if I converted this to an array using some sort of library. Convert to an array using some sort of library. All right, all right. Let's see. Let's peek into the world of cheating. What is this? Turns the binary number using bin. Okay. From everything from the second onwards of that binary array. Z fills. So converts it, makes it sure that's 32, reverses it, converts it back to an integer. I don't think I've ever used, well, if I ever used it, I have since lost knowledge of it. I mean, I've seen zfill, I think, it just spills out the string, or I guess in this case the array, to a certain bin. Bin function Python. Bin converts an integer to its binary representation as a string prefix 0b. So the 0b is what's removed when they do 2 and onwards. Index 2 and onwards is going to be the actual bits of that array, that string, I guess. Zfill makes the string back to 32. Reverse the string, convert it to an int. I'm not sure why you would need to have this here. So convert the int. Oh, when you convert the int, you specify what this string, I guess. Well, I guess this could be different data types, but if you're using string and you're converting to an int, the int would kind of be implied to be decimal, or you convert it to an integer, but you can say what the base of the thing that you're converting it from. So the base here is a binary number, because this is bin right here. I wonder. Yeah, you have to deal with the binary representation, right? You can't deal with the integer representation of the string, or the decimal integer representation of the string. Okay, well, kudos to that. Okay, summary. Definitely not optimized. Definitely not as optimized as possible. Best would be using bin plus zfill plus kind of array manipulation plus kind of int. But it is definitely understandable to me. This is going to a simple kind of for loop to iterate over the kind of least significant bits. Using bitwise and with 1 to get last, or the carry bit. Adding or appending that to the answer binary, and shifting the bits in the answer. So yeah, get the last bit using this, append it, or why did I need to do reverse times 2? Yeah, so the reverse answer shifts over by 1 to the left, appends the last bit, and then you shift over or I need to remove that last bit from the original n each time. So something like reverse starts with 0, and let's say n starts with 1 1 1 0 0 1. This isn't binary. N mod n bitwise and 1 is going to give you this 1 right here. And then reverse times 2 would shift over to 0, so it's now like in the front, and it's going to add like, it's going to be reverse like 0, 1 at that point after the first loop. And n divided by 2 would be n is equal to binary 1, 0, 1. And so on and so forth. Complexity of this can be O of n, where n is the number of bits. This can be 32 bit, 32 loop. Kind of in theory this constant. Might could possibly consider n as constant. So maybe O of 1, depends on how you want to think about it. Basically O of 1 since no extra space is needed. Wow, that wasn't easy, huh?